Welcome, everybody, to the weekly Quantum World Detangled, Season 2, Episode 9, Episode 10. We're not sure, but it will be awesome. I'm here with my friends.
Hi, everyone. Denise Ruffner from IonQ. I'm VP of Business Development, joining you from Southern California.
And good morning, everyone. Tommaso De Maria from Singapore, CEO of Entropic Labs. And today we have a special guest.
I am Dave Bacon. I am the VP of Software at IonQ, and I am calling from sunny Seattle.
And David, I'm going to embarrass myself more than you, hopefully, but I have to ask because it makes me laugh. What is it like to grow up with your last name?
Oh, it's awesome.
A lot of bacon, pig jokes. Did you embrace them? Did they bother you? Do you have any favorites? Tell us about your childhood.
It's a great name. Kids make fun of you, but you get a good thick skin. And then you can think about things like, what are you going to name your kid? You could name your kid Chris Peterson Bacon, which would be Chris P. Bacon. So you can have a lot of fun with it. So it's actually great unless you're talking to a vegetarian, and then it gets a little dicey.
Okay, you got to hang out with the meat eaters. I looked into your background a little bit, David, and we always try to get to know our guests personally. There was an interview I found which was very interesting, and you gave a couple really interesting answers in there. One question, and I'll be asking you that question in 20 minutes or so, was what would you be doing if not what you're currently doing? And your answer was you wanted to be a storyteller. I think stories are really powerful and underrated, but where did that come from? Why a storyteller?
Well, I was, as an undergrad at Caltech, I was both a physics and a literature major. And so, I always think a lot of life is about the stories we tell ourselves. And so, I think one of the most interesting thing, and you guys are probably experienced this, is sort of the stories behind everything that's going on. Quantum computing has a lot of stories. Some of them we hope probably stay down, but it's just sort of frames things for where we're going and what we're doing. And I think, to me, that's part of the human experience of going forward. I'm amused that I said that. I think these days I might also answer something like ski bum. That would be another good answer for me, or something like that. So quantum ski bum sounds like a good job.
And when you gave that interview, I think you were working in astrology. Now you work in quantum. Do you think about the intersection of quantum and cosmology, astrology ever? We had a guest in season 1 that made his job out of that question. But is that something that you're concerned with or dreaming of at night?
André, I think you refer to astronomy, right?
Yes.
Astronomy, yes. Yeah, I mean, I would my cosmology story was kind of funny because I went to grad school. When you go to grad school as a physics graduate student and you're a theorist, it almost always means you want to do string theory. At least that's when I was doing it. And so I sort of convinced them that's what I was going to do. But then I showed up and just took all the astronomy classes because I wanted to do astrophysics. And that was great. Like, it was like I learned a ton about stuff. But I realized that like the problems in theory there were things people have been working on for a long time. And quantum computing had just sort of started. And I looked over and there were like all these new questions that people were asking. And it was sort of like obvious that I was not as smart as the astrophysicist I talked to, but maybe this new field that everybody was scared of talking about because it was so new was the right place to go. So I sort of made that jump, and most of my graduate student courses were not useful for quantum computing. But I know a lot about the interstellar tedium, which is, the name people call the interstellar medium because there's so much tedious chemistry that goes on in it and complex stuff that, just boggles your mind. So
good. Well, let's dig into your quantum career, and I'll hand it off to Denise. I'll try my luck with one last bacon joke. Maybe this one won't get edited out. What do you call a pig that knows karate? Pork chops. Denise?
Oh, gosh. Okay. Well, so I did my research on Dave, and I found a website that was, I think, kind of deleted or just a shell called the Quantum Pontiff. And so I thought that would be a good thing to ask Dave about on camera. So Dave, tell us about the Quantum Pontiff.
Yeah, so I was an early blogger, fairly early, I guess. And I started a blog. I guess I started that while I was maybe a postdoc at Caltech, and then at the Santa Fe Institute, I was a postdoc there as well. And it was mostly, a place to joke among my friends about different random things, right? That's always how blogs start, right? And it was called the Quantum Pontiff. And there was a period where, like, if you search the word pontiff on Google, it would come up, number one above the dictionary definition of the Pope, right? So it's like more popular than the pontiff. And it was a lot of fun. I became part of this science blogs network that sort of infamously imploded at one point. And met a lot of, actually, from those times, one of the most interesting things is I just met a lot of people who were science journalists or involved in that sort of part of the world. And mostly this was just for fun. I spent a lot of times at that time arguing about D-Wave and whether D-Wave was a valid sort of, company to care about. And I'm sort of a D-Wave neutral person in many ways. And I would also mostly try to poke Scott Aronson and get him to say silly things on his blog, which I was sometimes successful at doing. So that was another fun thing to do. But it was a lot of fun. And at the same time, I actually wrote this website called Scirate, which was a place where people go and they basically, it was like dig for the archive. So all the quantum computing papers that come up, you would be able to vote on these papers, and they would sort of come up and as like the top of the list. And what's great is that was almost used exclusively by quantum computing people. So basically, my friends. And so for quantum, it's actually a really great resource to go through and look at these papers and see what people think is interesting. And when I left the field, it was even easier. It was great because I didn't have to pay attention. I would just go back to that website and see what people were actually interested in. So it was another fun one from that time.
Okay, so now it's True Confessions. Is that where Tommaso finds the paper of the week?
Yeah.
Well, a magician never reveals his tricks, right?
Okay. Well, so someone asked me about you today, and they said it was the best press release they've ever seen where a CEO cracked a joke during a press release about hiring someone. And they were referring to Peter Chapman telling the world that he granted you 3 wishes to come to IonQ. So maybe you could tell us a little bit about that.
Yeah, I mean, Peter's got a good sense of humor. So I had just recently, also while I was contemplating the job offer, gotten engaged. And so Peter's, the 3 wishes ended up being, a quantum computer with 100 logical qubits, quantum teleportation, and finding true love. And so, there's sort of a nice joke there about, he could give me all of these things. So the teleporter, I must admit, doesn't work very well. It just moves me a couple steps across the room. So I may have to return it to him. So,
well, that's great. I'm honored to be working with you at IonQ. It's a pleasure to have you on the podcast. And I'm going to hand you over to Tommaso now.
Sure. Thank you, Denise. So, Dave, I know that in your, you have done a lot of things in the last few years, as you've just shared. But you, despite coming from physics, you have a lot of experience in software engineering. Maybe you can share a little bit about how that happened.
Yeah, so I was a professor at University of Washington in the computer science and physics departments. And one day I literally kind of just woke up and said, I'm going to apply to Google to try to get a job. And then I had one of probably the most amusing interviews of all time because, they do these really hard coding interviews for you and things. And, as a professor, I took my students' data and used Python scripts and munged it together. I didn't write a lot of real code. And I know now, having done hundreds of interviews, that my interviewer was like, 2 of them I nailed, and 2 of them I got a 0 or a -10. But somehow they sort of let me come over, and I just decided, I was doing quantum computing. I'd been doing it for about a decade then, working in error correction and algorithms. and I just decided to try something crazy. And so I went and joined Google and became this sort of a real software engineer. I worked in ads, which everybody at Google does. I learned to code. And then I helped build a domain registrar of all things. So registering, debacon.org or whatever website. Most notoriously, Google domains accidentally let somebody think that they bought google.com at one point. So I got yelled at for that by important people at Google. So that was fun. And then about, I guess it's almost 4 years ago, I got this opportunity to go back and join the Google quantum team and build software for them. And so this was when John Martinez from UC Santa Barbara moved over to join Google. And really that's when Hartmut Nevitt had been doing quantum stuff before then. They'd been sort of benchmarking D-Wave's machine, and Hartmut had been doing some other things. But that was sort of their first serious step into doing, gate-based quantum computing. And so I joined that group and I helped build their cloud service and the software for writing programs that Google built, Circ, as well as sort of running the team that does all the software for that stack. And so it's a lot of fun. Software, there's a lot still to build right now in quantum computing for software. So it's sort of like if you have the ability to, both write code and also know the quantum computing side of the world, you're just like a kid in a candy store, right? Because it's just tons of stuff to do.
Right, exactly. So I love the last comment, and I agree with that. Maybe we can spend a few words about it. So what do you think are the opportunities in quantum software development, whatever that means, in the next few years? Will there be demand for it? Is it even fair to think about building software specifically for quantum computing? And if you think there will be demand, for what?
So there are lots of ways to attack that. So one is, for the people who are actually doing the hardware and building the quantum computers, software is incredibly important, right? You really have this, quantum computers themselves are incredibly parallel, and you have control problems at that next level up, which are incredibly challenging, right? This is sort of, the best people in the world are needed to sort of work on that system and build it, right? So that's sort of, for people who are, this is very, very much not like a lot of other programming that you do. So there's a lot of if you can do that type of work, you're golden. As you move up the stack, then there's this sort of, there are all these frameworks or programming languages that people are developing. And right now I would say it's at this point where there's just a bunch of diversity. People are sort of groping for the right things to do. And we'll look back at this era and kind of laugh at it in the sense of you do that for programming languages. You look back at sort of BASIC or things like this and you're kind of oh, that was an interesting idea, right? But we're sort of at that. We just don't know the right abstractions there. I got to work on building one of these Circ, and I certainly today would build a similar, but I would learn a lot from what I did there, right? And so we're sort of at the beginning of that sort of thing. And so there's a lot of stuff to build there for enabling people to sort of program the quantum computers. The place that I actually think is the most interesting that is less talked about are tools for helping people reason about quantum problems like quantum algorithms or quantum error correction. And there we don't have as many, I don't feel like we have as much work that's going on there. There's a lot, but it's just it's not quite as impactful yet. So the example I give is I had a report at Google named Craig Gidney. Craig did not know quantum computing. He was working in sort of at one point in security and then just sort of as a normal software engineer. And he built a visual editor for quantum circuits. He could drag and drop things around, and then it sort of animated the outputs of these things. And he basically taught himself quantum computing using that tool. And then what's amazing is because he built that tool, he started working on problems that people had been sort of thinking about for how to, make smaller circuits and things like this. And he was able to sort of develop an intuition about this. And he, to watch him use it, it's sort of like watching a cyborg. He's talking about this problem and he's moving all these things around and you're watching the animation sort of go. And he was able to use the tool basically to, you know, come up with results and prove things that, you know, people have been working on for a long time and improve, you know, some basic circuits in error correction and in factoring and things like that. So there's like tremendous opportunity in that space where, you know, like one of the things we'd like to do is program, you know, quantum chemistry. But these algorithms are pretty big. How do we shrink them, right? And, you know, we're just at the beginning of people building the tools to help us even sort of approach that problem. And so I'm very excited about that type of work. Sort of helping us do better things like that. So I mean, go ahead.
No, sorry. Go ahead.
No, I was just gonna say. I mean, this sort of ties in with there's a whole other direction to go, which is compilers and also applying machine learning to quantum computing. Right? We're still at the infancy of that. There's this great battle going on between physicists who tune up these devices and run, say, calibrations or things like this that they've spent, you know, years figuring out how to do, right? Like, you know, Google likes to show this picture of the graph they use for calibration, and they point at like one node and say like, that was a PhD thesis, right? And that's a lot of hard fought knowledge, but a lot of the calibration stuff is really optimization. And there's a class of people who think, oh, machine learning techniques will be useful for tuning these machines up. And so there's this battle because the physicists are like, oh, this is all our hard knowledge. And machine learning people are like, just give it to us as a black box and we'll beat you. And, you know, that's, who knows, it's probably going to be a mixture of both, but it's kind of fascinating to watch that sort of battle for how we actually program these things play out. So
I love it. And do you think we can learn something from like the history of classical or conventional computing? Like, are you seeing a lot of parallel between what happened in the 50s and the 60s and what is happening today in, you know, in the quantum computing industry in terms of software development? Or is it even too early to say something like that? I
think, I mean, the real difference is we now live in a world where like the computing abstractions exist in the classical world, and they really help us. I mean, they're immensely helpful, and we just sort of take them for granted these days, right? When I build a system now, I just have all this tooling and stuff that I do that I didn't have before. There are sort of, you know, places where people are going, you know, I think there's still sort of these missing layers of abstraction, right? Like, what are the crazy abstractions we can use to actually understand quantum speedups? And this is, of course, like the mystery of quantum algorithms that we have. You know, we have different ways of talking about it: interference, entanglement. You know, but they're all sort of, you know, if you ask, you know, when you ask people who say like, what is giving it the power? We don't have a way that really gets at it in a way that then I can then turn that into code. Right. And that's like a missing part of the story. I think a lot of people are excited and trying to think through how that works. And I suspect, you know, especially with how many people now are entering the field, we may be making a lot more progress on that. I still think not enough people work on algorithms themselves, which is, you know, that's the other thing that happened in the 50s, right? All the algorithms that we now use, you know, the base algorithms were developed, right, as sort of like, you know, oh, and then, you know, Edmonds came up with his algorithm, right? That type of like these very classic algorithms. And we have a couple of those in quantum, but we really haven't had the same number. And I still think that's one of the big missing pieces in our industry.
Thank you. Yeah, this is very interesting. I'll pass it to André, who I believe has a few questions for you as well.
Our Marshall Bruce quantum questionnaire, 12 questions for you, Dave, and your challenge will be to, you know, give us a personal, emotional answer, one word to one sentence. It's about how you're feeling and your gut, no right or wrong. So if you accept that challenge, we'll get started with the first one.
Go for it.
Dave, what is the principal aspect of your personality?
Joy.
The quality that you desire most in an entrepreneur?
Fast.
The quality that you desire most in a scientist?
Creative.
What is your best virtue?
Laughter.
Your principal flaw?
Ego.
What do you appreciate most about working in quantum technologies?
People.
Develop. Why?
Just the people who are doing this are trying one of the hardest endeavors humanity's done. Right? It's a pretty awesome thing to be a part of.
And if not working in quantum technologies, or as a storyteller, or as a ski bum, what would you be doing?
Oh, you took off my ski bum, and you took off my storyteller. That's like the two big ones. I guess I would. I would be building a product, some other product, and bringing it to the world. I got a lot of joy out of building just a domain registrar. So I would be building something for the world. What? I don't know.
Who is your favorite scientist?
This one's a killer because I can't have a favorite. Okay, I'll tell you a favorite because I'll tell you my favorite scientist is Barbara Terhall, who is a researcher in quantum computing, who is one of the most fearless researchers I've ever met and does things for the best reasons. So I'll put Barbara at the top of my list.
Very nice. Who's your favorite entrepreneur?
Come on, Peter Chapman.
Yeah, let's say Peter. There we go, Peter. I'm trying to think. I mean, I have friends who are that, so I apologize to them. So let's say Peter.
Peter Chapman, CEO of IonQ.
There we go.
Okay, the next question. I've gotten an answer to it only once. And since you come from Google, which is superconducting, now you work at IonQ, which is ions, I really hope I'm going to get an answer from you. What is your favorite quantum computing modality?
I'll say ions, but if you ask me in 5 years, what'll I say? Yes, ions. I will say ions. I'll just throw down the gauntlet. Everybody else is wrong, and I'll change my mind in 3 years when I come up for air.
What is your quantum dream?
Oh. Unique sync orientation problem. That's my quantum dream. That's a good one. Nobody knows what that is.
No, I have no idea.
It's a problem that is not known to have an efficient classical or quantum solution, but is in this complexity area that it could be. And it's sort of one of these. It's sort of a not as well known as it should be. But if you could solve it, it would have a major. It would be sort of equivalent to finding Shor's algorithm. It's a place where there's hope for quantum computers in sort of doing something amazing, and it's a problem that I've worked on off and on for many years now as sort of a hobby. And so I will say that's my dream, because the dream is that quantum computers can actually solve that problem, because that will really change the world. So.
Okay, we'll get a paper or reference from you and share that along with this video. What's your biggest quantum nightmare?
What is the biggest nightmare? I think we will go through a quantum winter, but I'm not worried about that. It's sort of just a natural cycle that occurs for many people. I don't worry too much about that. The worry could be that I think my biggest nightmare is that at some point we figure out that the speed ups that quantum have are just not ubiquitous enough. That's probably the biggest nightmare. Like that really
is an answer we've gotten a couple times over the last few weeks. Certainly a topic that's top of mind for many. So you believe you'll be on the winner and not loser side of all of this. Imagine tomorrow we wake up and you have the first universal quantum computer, completely fault tolerant, even more logical qubits than Peter would ever give you. Who would you give that computer to?
Can I say who I wouldn't give it to?
Creative liberty.
No, who would I give it to? I mean, the biggest place where we're gonna have a lot of fun is, sort of in the world of chemistry. So I'm gonna go down to Caltech and I'm gonna find Garnet Chan and I'm gonna say, here's a quantum computer to use. I mean, I'm gonna write some programs for it myself and use it, and then I'll give it away.
Okay. So first tips go to you, but then we attack the big problems. Dave, thank you so much. It was a pleasure having you on. I promise to come up with bacon jokes that will not be censored by my very strict oversight board. I would like to thank IonQ, our sponsor, and my friend Denise Raffner, our sponsor Entropica Labs, and friend Tommaso De Marie. And this concludes Season 2, Episode 9 of the Weekly Quantum World Detangled. You are now detangled.